So this is the fourth page of the worksheet. Right, so this page I've given you three different SSA triangles. And these are all the three different situations that occur, right? So no solution, one solution, or two solutions. Okay, so first let's look at the no solution, right? So what are we given? So we're given that A is 11, side C is 7, and then angle C is 82 degrees. Okay, so here C is completely known, right? Because we know both the angle and side C, and then we also know side A. So let's try to figure out angle A, right? So using the law of sines again, right? So then let me write the law of sines this way, right? So sine A over side A is equal to sine C over side C. Right, so it doesn't matter if I put the angle on top or the side on top. So here I put the angles on top. So what do we get? Right, so sine A over 11 is equal to sine C, which is 82 degrees, over 7. Then the 11 multiplies over. Right, so you get sine A is equal to 11 times sine 82 degrees over 7. So sine A is equal to, so let's calculate this, right? So what do we have? 11 times sine 82 divided by 7. So we get about 1.556. Okay, so we get this. So you have to be careful about how you interpret this, right? So 1.556 is not the angle, right? It's the sine of angle A is 1.556. And then this is the situation where, as I said previously, the sine of an angle should always be between -1 and 1, right? So it should never be bigger than 1. And so this is the case where we run into this situation where the sine of the angle is bigger than 1, so that there's no solution, right? So this is impossible. So there's no solution. Okay, so any questions on this first example?
Wait. So we're just gonna leave it off as like can't solve. That's it.
Yeah, right. Yeah, it's impossible to solve because, I mean, you'll see exactly why you can't solve this, right? So I mean, here we want to figure out what angle A is, right? So if I were to try to solve it, I would need to take the inverse sine, right? Because the angle is unknown, right? So you can see that if I were to calculate it, I would have to calculate it this way, right? So inverse sine of 1.556, but you'll see that this is impossible. So it gives you an error because it's just not possible to calculate this.
Okay, got it.
But in terms of, like, say if this were my open math, you would have to type in DNE for does not exist.
All right.
Okay. So again, be careful about differentiating between the angle itself and the sine of the angle, right? So what you're looking at here is that the sine of the angle is bigger than 1. That's the situation where there's no solution. Okay, so let's look at the other two cases, right? So either one solution or two solutions. So what information do we have here? So we know angle A is 88 degrees, side A is 110, and side C is 54. Right, so this is again an SSA triangle, right? So S, S, and then A. So we have an SSA triangle. So we know A completely, right? So both the side and the angle. So to get angle C, again, I can set up the law of sines. So I just write out, so sine C over side C is equal to sine A over side A. And then now we plug it in, right? So sine C. Oh, but by the way, if you look at the trig cheat sheet, it has the law of sines and cosines on the very last page, right? So this was the formula sheet that we've been using the entire time. The law of sines and cosines is on the last page, except so they still have side A, B, and C, but then for the angles they call alpha, beta, and gamma instead of the angle A, B, and C, but it's exactly the same. I mean, the reason they use the Greek letters for the angles is because you can see when I write things out, I mean, A and B are okay, but lowercase c and uppercase c looks exactly the same, right? So sometimes it's hard to tell them apart. This would be angle C, where uppercase C is bigger than lowercase c. But in any case, so let's continue, right? So side C is 54, and then angle A is 88 degrees, and then side A is 110. It's again the 54 multiplies over, right? So what do I get? So sine C is equal to 54 times sine 88 over 110. So what is this equal to? So let's calculate this. So 54 times sine 88 degrees divided by 110. So you see now this is okay, right? Because now I have a number that's smaller than 1. So let's say to reduce the amount of error, let's take, say, 5 decimal places here. So 0.49061. But again, this is just the sine of the angle. So to get the angle itself, I need to do the inverse sine. So what is this equal to? So inverse sine of this. Inverse sine. So instead of typing it out, I'm just going to use the previous answer that I've just calculated. So it's about 29.38 degrees, or 29.4 degrees. Let's say round it to 1 decimal place. Okay, so again, at least this part is okay, right? Because I get the sine of the angle is smaller than 1. And then to get the angle itself, I just do the inverse sine function. And so this is what I'm calling theta. Right? So the thing you want to check is 180 minus theta. Right? So you have theta, which is so you have theta, which is 29.4 degrees, right? So we also have to check. Let me check over here. So check 180 minus theta. Okay, so that's 180 minus 29.4 degrees. So what is this? This is about 150. 150.6 degrees. Except you'll see that this is impossible, right? So what is this? This is still angle C, right? So this is for angle C. And if angle C were 150, right? Angle A already was 88, right? So if you add 88 plus 150, this is clearly more than 180 degrees, and that's impossible, right? Because as we said, the three angles in a triangle should always add up to 180, right? So angle A plus angle C is bigger than 180 degrees, which is impossible. And so this is the situation where it's not possible to have an obtuse triangle. And so for angle C, this is the only possibility. Okay, so we know angle C, right? So this is angle C, and then now we know two angles, right? So A and C. So angle B is just 180 minus 88 minus 29.4. So what is that? So 62.6. So that's angle B. And what else is where we need side B, right? So side B, I can just use the law of sines. So, A was the one that's completely known, right? So B over sine angle B is 62.6 is equal to A. What was A? A was 110, and angle A is 88. So B is, so I multiply this over. So 110 times sine 62.6 over sine of 88. So what do I get? So 97.7. Okay, so this was the case where you only have one solution because the obtuse angle for C is impossible, right? And so again, you can compare the size and angles to make sure at least there's no problems there, right? So you see between A, B, and C, A is biggest, then B is second, and then C is smallest. In terms of the angles, A is the biggest angle, then angle B is the second, and then angle C is the smallest. Okay, so that's the case where we have one solution. So any questions on this example? Okay, so let's move on to the problem where we have two solutions. So what's given in this problem? So angle B is 40 degrees, side B is 22, and side A is 30. So be careful because I've oriented A, B, and C differently in these triangles, so they're located in different places. But in any case, again, we have an SSA triangle. So side B is completely known. I know side A, so from there I can try to get angle A using the law of sines. So let's set that up. Right, so sine angle A over A, which is 30, is equal to 20 over 22 over sine B, which is I've reversed this, right? I want the angles in the numerator. So sine angle B, which is 40 degrees, over side B, which is 22. So the 30 multiplies over. And so sine A is equal to 30 times sine 40 degrees over 22. Sine angle A is equal to, so 30 times sine 40 over 22. And then I get 0.87653. So again, we see that the sine of the angle is smaller than 1, so this is okay. Right, so this is okay. And so to get the angle, I have to do the inverse sine. So what is this inverse sine? So we get about 61.2 degrees. So again, this is theta. So I have to again check 180 minus theta. So 180 minus 61.2 is equal to, what is this? Less than 120. 180 minus 61.2 is 118.8. And so you'll see that so angle B plus, okay, so this is for angle A, right? So this was for angle A. So angle B plus angle A is less than 180. So this is okay. So this is the situation where we have two possibilities, right? So the first possibility is that A is 61.2 degrees, and the other possibility is that A is 118.8 degrees. Right, so so 61.2 degrees or 118.8 degrees. And both possibilities are valid. So in this situation, you would have to solve each of them separately, right? So when angle A is 61.2 degrees, right? So angle C, right? So I'm kind of running out of space here. So so angle C, you would do that separately, right? So you have 180 161.2, and then what angle B was 40. So in this case, angle C would be 78.8, or angle C, in the case of the other case, would be, so you again do 180 minus 40, and then now 118.8. So 21.2 degrees. So what you have to do now is take each possibility for angle A and then continue from there, right? So side in terms of side C now, because there should be angle C, capital C. In terms of side C, again, for each of these two angles, you have to calculate side C separately, right? So again, I'm kind of running out of space, but you use the law of sines for side C, right? So you would do C over sine C is equal to relate to side B because that's where it's completely known, right? So 22 over sine 40. But again, I'm kind of running out of space here, so let me just calculate it, right? So when angle C is 78.8, what do we get? Right, so that multiplies over. So 22 times sine 78.8 divided by sine 40. So in that case, side C is 33.6. In this case, C is, again, you have to calculate it separately. So now, so 22 times, and then sine of this thing, 21.2 divided by sine of 40. So if side C were 21.2, then if angle C was 21.2, then side C would be about 12.4. Okay, so those are the two solutions, right? So you have to solve them separately because when A is different, angle C is also different in both cases. Okay, so any questions on the situation where you have two solutions? So again, the SSA triangle is the one you want to be careful about, right? So so first you have to make sure that whether the sine of the angle is smaller than 1 or bigger than 1. If it's bigger than 1, there's no solution. If it's smaller than 1, then you're okay. But then you have to get the angle and then determine if the angles are possible or not. Okay, so that's the SSA triangle, and so that's the law of sines. So what about the law of cosines?